What if the software your AI assistant writes is functionally perfect, but secretly toxic to your codebase? While we obsess over whether code works, a silent crisis of maintainability is emerging, where messy, unreadable code accumulates as technical debt. Most current research evaluates large language models based on whether they generate code that runs correctly. However, the researchers argue that simply passing unit tests ignores the long-term cost of technical debt, such as duplicated logic, poor structure, and violations of coding standards. To measure this debt, the authors focus on code smells, which are symptoms of deeper design or implementation problems, rather than bugs. These range from local implementation issues, like using magic numbers, to broader design flaws, such as poor encapsulation or overly complex class hierarchies. To objectively assess quality, this study establishes a baseline using human-written reference solutions from textbooks and top-rated Stack Overflow answers. They then calculate the rate at which large language model code increases smells compared to these professional human standards. Using the ScenEval benchmark, the researchers tasked 4 models, including Gemini Pro and ChatGPT, with solving 1,000 coding scenarios. They then employed static analysis tools like PMD and CheckStyle to automatically detect and count the smells in the generated output. After running these extensive comparisons, the results reveal a significant gap between human and machine code quality. The primary finding is stark. Generated code contained an average of 63% more smells than the human baseline. Surprisingly, while Codex had the highest increase at nearly 85%, the open-source Falcon model performed the least badly, with only a 42% increase. The quality of the code depends heavily on the topic. While the models performed reasonably well on basic exercises and regular expressions, they struggled significantly with object-oriented programming concepts, frequently failing at encapsulation and inheritance. There is a strong correlation between difficulty and declining quality. As task complexity rises, the number of smells in model-generated code skyrockets compared to humans. Interestingly, while correct code is usually cleaner, Falcon's incorrect solutions actually possessed fewer smells than its correct ones. The analysis pinpointed specific habits where large language models fail most often. They frequently rely on magic numbers without explanation, neglect proper documentation, and struggle with basic code alignment and placement within files. It is important to note the boundaries of this study, which focused exclusively on Java and relatively small single-class tasks. Consequently, broader architectural smells that emerge in large-scale systems remain an open area for future investigation. To learn more, head to emergentmind.com.